Here is a short 17a example on how to find the vertical and horizontal asymptotes of a rational function. So we've got the function. Hope you guys can see this. I'll read it to you. It's f of x equal to x squared plus 6x plus 5 over 2x squared plus 9x minus 5. And to be able to find, well, so first of all, looking at this function, we can already see what the horizontal asymptote is. The horizontal asymptote is y equal to positive 1/2 because the degrees are the same, they're both 2. And the quotient of the leading coefficients, well, the leading coefficient here is a 1, so you get 1 over 2, which is 1/2. You can also do more work and take the limit to infinity of all of this, x squared plus 6x plus 5 over 2x squared plus 9x minus 5. I don't think your teacher really intends for you to do it this way, but you could. And then you could divide everything by the highest power of x in the denominator. I'm going to simplify it so I don't have to do too much work here. X squared divided by x squared is 1. 6x divided by x squared is 6 over x. 5 over x squared is 5 over x squared. 2x squared divided by x squared is 2. 9x divided by x squared is 9 divided by x. And negative 5 divided by x squared is negative 5 divided by x squared. And then as x goes to infinity, all of the things divided by x to some power end up going to 0. So, oh yeah, we do get 1/2. For the vertical asymptotes, you're trying to find the places where the function is undefined. Well, not exactly. So it's all the places where the function is undefined that haven't already canceled out. So if you looked at this, so this factor is, by the way, the top factor is x plus 1 times x plus 5. The bottom factor is 2x minus 1 times x plus 5. And the way I did that was I was looking for numbers that multiplied to 2, so I got 2x and x. I was looking for ways that multiplied to negative 5 that got me the right middle term. So I actually tried a few things. If you look here, right, negative 1x plus 10x gives you a 9x. So there's a couple different ways we can factor that. If you have questions about factoring, you can certainly ask me, and I'm happy to talk about it. I don't want to waste my time here doing that. So to find the vertical asymptotes, you first have to cancel out any common factors. And then whatever values of x make the denominator 0 now are going to be vertical asymptotes. My function is x plus 1 over 2x minus 1, except we know that x wasn't allowed to equal negative 5, because if x was negative 5, we'd have 0 over 0. What we do have is we actually have a whole at negative 5. So we end up with this function, x plus 1 over 2x minus 1, which has a vertical asymptote when the denominator is equal to 0, which is at x equal to 2x equal to 1, x equal to positive 1/2. The reason I don't love this is because it's purely a coincidence that this 1/2 value here for a vertical asymptote is the same as our horizontal asymptote value, right? I could have made this easily different where the values are different, so I don't love that. Why don't we do another example on the other side? Also, by the way, if you were taking the limit as x approaches negative 5 of this x squared plus 6x plus 5 over 2x squared plus 9x minus 5, you would exactly be taking the limit of this expression after you cancel that, and so you get the limit as x approaches negative 5 of x plus 1 over 2x minus 1. And you plug in the negative 5s. And negative 5 plus 1 over 2 times negative 5. Negative 10 minus 1, so you get negative 4 over negative 11. So this function would have a whole at negative 5 comma 4 over 11. And let's do one more example. Something not too terrible. Something like the function x squared minus 5x minus 24 over, I don't know, x squared, sorry, I'm trying to think here, minus 5x plus 6. So again, we'd have a horizontal asymptote, y equal to 1, because degrees are the same, quotient of leading coefficients is 1 over 1, which is 1. The vertical asymptote, well, if we're not careful, if we just factor the denominator, and let's make sure I've done this right. Let's see. Actually, I want to make this a plus 24, which doesn't change the horizontal asymptote. The denominator factors as x minus 3 times x minus 2. Right, those multiply to positive 6, these add up to negative 5. And if we weren't being careful, we might think we had a vertical asymptote of both x equal to 3 and x equal to 2. But we don't, because the numerator factors as x plus 8. Darn it, I knew I did that wrong. I want the numerator to factor as x plus 8 times x minus 3, which means I actually should have a plus 5x here and a minus 24 here. Sorry about that. Still doesn't change the horizontal asymptote, which is 1. So then if this is actually what I have on top, these would cancel, and you have a vertical asymptote just at x equal to 2. You'd have a hole at x equal to positive 3. So hopefully that clarifies things a little bit as far as asymptotes go.